when I click the part design, we can have something appear on the left side. Thus, we work with the 3D scan. So just wait a little bit. Sorry. Okay, so when we click the part design, the 3D experiment application will be appear. So we need to connect to the internet and wait a little bit to the for the platform, which is how to say start the application. Okay. So if you have something that you draw before, but that you do before, but if you forget to save the file, the application will be appear with the restore or something like new section. For example, here I do not need to, to restore anything from the last section. I click on the new section. Okay, so wait a minute. Hold on. Yes. Maybe because my internet at home is not really good. Các bạn chào chút, tại vì là cái phần mềm 3D Scan này nó tương đối muốn RAM khi thầy thực hiện được xe, thế nên là thầy phải nốt lại. Someone. Không chạy. Okay, so now I can say. Okay. So here is 3D experience that we use for the yes the part design, and we come to the. I will ask you to the IT practice B2 from 2025. So we working inside this workspace. Okay, and now just give me a minute for the this. Something.
Thầy ơi cho em hỏi một tí ạ.
Em nói.
Lịch của bọn em thì nó đang bị trùng vậy ạ?
Thầy nhận được cái đấy rồi, thầy đã gửi phản hồi cho chỗ chị Hiền rồi. Thì các em chờ một chút nhé. Tại vì lịch này nó đang bị trùng cái này, đâm ra là thầy gửi rồi nhưng mà chưa thấy chị Hiền chị phản hồi đang mà. Thì có gì tí nữa nếu mà nội dung nào thì thầy sẽ trao đổi lại. Các bạn cứ học đi, đến 1 giờ 5 năm thôi đúng không? Hello?
Vâng.
Rồi, ok, cứ yên chí nhá, không vấn đề cả. Thôi được rồi, từ phần mềm này nó đang bị đốt chặn tại vì mạng internet nhà thầy nó không được nhanh lắm, nên là tạm thời chúng ta sẽ làm cái menu drawing trước, tránh trường hợp mà mất nhiều thời gian ở phần này. Okay, so because today I would like to introduce you the 3D Experience and teach you how to work with the 2D drawing. Before going to the first practice, but what you know, because you cannot install the software on your own computer as you before, so it's better for the manual drawing first. Okay, so rồi vì các bạn chưa cài nên bây giờ rất là khó để thầy biết được các bạn như nào cả. Thì phần manual drawing này ấy, thì các bạn có thể nhìn thấy, chờ thầy chút. Ở rồi cái bài menu cuối cùng mà các bạn cần vẽ vẫn là một cái hình 3D, và các bạn chụp lại cái hình này có thể ấy, thầy sẽ gửi trong các đôn, nhưng nhiệm vụ của chúng ta hôm nay là chúng ta sẽ vẽ được cái hình này là một. Thực ra cái buổi học hôm nay nó sẽ thiên về practice, tức là chúng ta sẽ có một cái buổi vẽ manual drawing, và đây là cái hình số 8 đấy, chính là cái bài số 8 trong tổng số 8 bài mà nộp. Thì hình này đã cho 3 hình chiếu đứng, chiếu bằng và chiếu cong, và các bạn vẽ lại cho thầy hình chiếu trục đo isometric ấy. Với cả buổi học hôm nay thì thầy mong muốn là giới thiệu về phần mềm 3D Experiment. Thực ra vẽ cầm tay chỉ việc nó sẽ dễ hơn, bởi vì hôm nào đến buổi thực hành nếu các bạn chưa từng bao giờ dùng phần mềm này hoặc chưa cài bao giờ, chưa được đến bao giờ, thì chắc chúng ta phải mất ít nhất 1 tiếng đến 2 tiếng loay hoay cái việc tài khoản rồi với cả cài phần mềm, nên nó rất là tốn thời gian ở cái phần đấy. Và thầy thì thầy đang lo lắng là trong cái trường hợp của các em không được thực hành nhiều, phần mềm không được cài trong máy của các em chẳng hạn, thì các em chỉ có cái số giờ thực hành tương đứng ở trên lớp, và số giờ đấy thì trừ khi bạn nào thực hành rất tốt ở trên lớp, còn không thì lúc đi thi final examination thực sự là khó từ góc độ nhìn của thầy, và thực sự khó các bạn. Thế nên là lời khuyên của thầy là nếu bạn nào đã có máy tính xách tay rồi, máy tính cũng tương đối mạnh, dĩ nhiên ở đây là đừng quá yếu, thì các bạn nên cài thử và chạy thử phần mềm này ở nhà. Trong trường hợp mà trên lớp các bạn không thực hành đủ thì các bạn về nhà ít nhất là bạn còn có phần mềm để làm cái bài đấy, và thực hành thêm bài khác để trong trường hợp là các bạn đi thi ấy, có đủ khả năng để các bạn làm bài, chứ không là thầy sợ là trên lớp chúng ta không thu nhận, tức là giờ thực hành ấy các bạn không làm nhiều, và đến khi thi thì chúng ta sẽ không có phần thực đủ kỹ năng để các bạn thi. Thì đấy là lời khuyên thầy. Có thể hôm nay các bạn chưa cài nhưng mà các bạn về thực bài thì trong trường hợp không chạy được thì không nói gì cả, nhưng trong trường hợp mà chạy được thì lên cả. Lời khuyên của thầy là lên cả. Thế thôi, đấy là lưu ý của thầy đối với phần đấy. Thế còn đối với cái phần technical drawing về manual thì đây chính là bài cuối cùng, các bạn có thể lấy giấy ra vẽ. Còn cái kia thì thầy đang gửi, có thì thầy sẽ gọi điện hay chị Hiền, bây giờ tầm này nó đau một vài hai thì cũng hơi khó một chút. Chờ một chút thì thầy sẽ gọi khoảng tầm 11:30 thì ấy, thầy sẽ gọi, thầy nhắn tin rồi nhưng chưa thấy chị trả lời, thì có gì thầy sẽ phản hồi lại ngay cho các em. Em lấy giấy ra thực hiện việc vẽ manual drawing cho các bạn này trước, rồi thầy sẽ khởi động phần mềm. Ok. Nào câu hỏi, if you have any question related to the course or anything, so please raise your hand and ask me.
Dạ thầy ơi,
Rồi em nói.
ờ, không biết lúc nọ em thiếu bước gì, nhưng mà hình như là em chưa tạo được cái tài khoản 3D Experience, thầy gửi lại cho em được không?
Ok. Email của em là thì em gõ trong cái nhóm chat thì thầy có một cái rồi.
Vâng ạ, vâng ạ, em gửi đến chat ạ.
I it was cái Nhật Bản qua sao bạn thấy Rồi, thầy vừa gửi tới bạn về phần mềm 3D Experience. Cái bài tập kia thì tí nữa thầy sẽ share lại cái màn hình. Trong trường hợp mà các bạn bị trùng hai môn bởi vì thầy gọi điện cho chị Huyền chưa được. Nên là tí nữa nếu có thông tin đầy đủ thầy sẽ chia sẻ lại. Chứ còn đây là cái phần mềm 3D Experiment mà các bạn sử dụng. So here is a 3D experiment that we use for the drawing 2D and 3D. So with the part design, you can see on the left side that related to the Katia design. On the right side, some people when you install with the when you register other a member of the design or 3D experience, sometimes you do not have the action part here. So if you want to show action part, for example, if you open your application and you didn't see on the left side menu, they call the tree and the right side for the action part. You should click the right button, right mouse, and click on the display and get the sub menu of the action part. So when you click the action part, you can have the right sub menu called action part on the left. And the left side, you click on this and you can see the pin here. Pin that means all the key will be appear. Even you do not click on this. So for example here, is even you click left mouse on the center or on the workspace, the key is not disappear. So this is related to the pin. If you click unpin, you can see it's only open when you move the mouse on the left side. So I prefer to fix this, or we could pin the key on the left side. So for the drawing 2D drawing, you should choose the plane that you work for the 2D. Here you can choose any plane. For example, here I choose YZ for the plane. Okay, and when I click on the left side, when I click this, and I click, you can see the blue color on the plane. And when you working with the 2D drawing, you should choose the sketch. So sketch symbol is it is a pencil on the paper. So you can see here, for example here, when I click on the plane and the sketch button, they will open and the menu on the bottom will be changes. Here we have a standard sketch, analysis, view, AR, VR, tool, or touch. Normally we work mostly on the standard and sketch. So for example, here if you want to draw, or for example, the rectangular, you click on the rectangular. But for the 3D experiment or another software such as CATIA, SolidWorks, they always have a grid. Grid here you can see that is grid of 100 millimeter multiplied with 100 millimeter. So grid is better when you want to touch the point. For example, if I want to draw the rectangular here, you can see that's on the left and on the right on the line of the grid, right? But sometimes you do not want the program to cut the point. So you want to close the grid. For example, here I can close the grid by click the view menu and click on the grid here. So you can see the grid disappear. For example, here when I turn on and again for the turn on. Okay. Another thing is very important before you have the first practice is working with the constraint. Constraint is very powerful tool for technical drawing. You can see here we have the constraint here. So constraint is you adjust the size of the figure For example, here I can constrain, yeah, it's 300, but I want 200. I just click, and this is reduced to 200. And the width, if I want to change 50, that will change 50. And another thing is very important for you is if I change 200 here, 300 here, you do not know exactly where it change, of course they change the size, the length of the figure, but we do not know that the figure will be moved to the left or moved to the right to change the length of the figure. Or if you change this is 500 for the city here. Sorry, just wait me a minute. I have a full book. Thầy vừa mới chị Huyền vừa mới gọi điện cho thầy thì chắc là có gì thì chị Huyền sẽ thông báo lại cho các bạn. Okay, cái đó. Thầy hỏi trước là cái môn Fluid Mechanics ấy là môn dạy lý thuyết à hay là đang là thực hành? Hello. Buổi đầu tiên à? Lý thuyết à đúng không? Hello. Lý thuyết à? Rồi ok, thế có gì để chị Huyền chỉ lý trong một lại với các bạn nhé. Tạm thời chúng ta cứ quay lại cái phần đấy, thôi được có thể thầy giảng nhanh cái phần này không để trong trường hợp có đồ tiết thì còn biết được. Rồi bây giờ quay lại cái phần mềm một chút này, thì thầy giải thích cái phần này nó rất quan trọng nên thầy phải giải thích cái này chứ không để mấy nữa các bạn sẽ trong vẽ kỹ thuật 3D ấy, thì bất cứ một cái phần mềm nào ấy các bạn cũng có thể thay đổi được kích thước. Tuy nhiên việc thay đổi kích thước hay ứng xử kích thước nó sang trái hay sang phải. Ví dụ như trong trường hợp này chẳng hạn, bạn đang đặt kích thước của hình chữ nhật là chiều rộng là 300, là chiều cao là 60, vậy là đây gọi chiều dài đi, hoặc là chiều rộng là 60. Thì khi chúng ta muốn thay đổi kích thước bao nhiêu thì đấy là một trong những ưu điểm của cái phần mềm vẽ của chúng ta, đó là chúng ta hoàn toàn có thể thay đổi được kích thước của nó. Ví dụ như chúng ta thay đổi 100 này. Tuy nhiên ở đây ấy, thì các bạn sẽ thấy này, ví dụ ở đây thì nó sang phải, mấy lần thì nó sang phải, ở đây nó cũng có thể là sang trái hoặc tiến lên, và chúng ta không biết được cái hình của chúng ta nó sẽ tiến lên lùi xuống, tiến lên hay lùi xuống cái gì. Bởi vì nó tùy thuộc vào cái ứng xử, bởi vì ở đây chúng ta chưa fix một cái gì theo một cái chiều nào cả. Thế nên là về cơ bản thì cái này nó gọi là unconstrained, có nghĩa là chúng ta chưa có fix cái gì cả, nên là nó có thể thay đổi kích thước rộng là bên trái hay là rộng là bên phải, hoặc là lùi lên, tiến lên trên hoặc lùi xuống dưới. Thế thì trong vẽ kỹ thuật 3D thì không phải chỉ có một phần mềm 3D Experience này, mà còn những cái phần mềm khác nữa thì người ta có một khái niệm đó là kích thước đầy đủ, hay là có những cái điều kiện đầy đủ cho hình vẽ. Thì ở đây có những điều kiện đầy đủ ở đây thì các bạn hiểu rằng là khi chúng ta đã xác định các cái giá trị fix ở đây có nghĩa là cố định, khi chúng ta đã cố định được điểm theo một cái điểm mốc ở đấy thì sau này thay đổi, bởi vì cái điểm ấy nó đã cố định rồi nên là cái điểm tương tự ở đấy khi mà chúng ta thay đổi kích thước ấy, nó sẽ bám theo cái điểm cố định trước và nó sẽ theo cái chiều đấy. Có nghĩa ở đây là nếu muốn cụ thể ở đây ấy, giả sử bây giờ thầy sẽ fix thì việc đầu tiên chúng ta fix này, một là cái tâm này nó trùng với cả cái tâm của cái hệ trục tọa độ hay còn gọi là tâm ô. Hai là nó khoảng cố định rồi. Giả sử ở đây khi chúng ta chọn kích thước này chúng ta cố định thì ở đây mới được hình chéo thôi, đúng không ạ, mới được cái khoảng cách đường chéo. Thế còn chúng đường chéo thôi. Về đường chéo này thì về cơ bản thì nó cũng chưa hoàn toàn đúng không, đúng không ạ, chúng ta cần cái góc nữa. Thế thì để kích hoạt được cái này thì việc đầu tiên là chúng ta cố định ở đây chẳng hạn, đây là theo phương ngang, còn ở đây là theo phương dọc như này chẳng hạn. Rồi nếu chúng ta đã cố định cái này là 50 và trên này là 90 thì cái điểm này các bạn nhìn thấy không, cái hình này bây giờ nó đã chuyển thành hoàn toàn là cái màu xanh rồi. Có nghĩa là cái hình này nó đã được fix, tại vì là cái tâm và cái điểm ở đây nó đã cố định với cái này. Sau này bạn thay đổi thì nó chỉ thay đổi được cái chiều ở chỗ này thôi chứ nó không thay đổi cái điểm này, nó gần như nó sẽ không xê dịch. Giả sử thầy thay đổi cái 50 cho các bạn nhìn nhé, trên 60 thì nó chỉ có thò xuống thôi chứ nó không thò ngược lên trên nữa, bởi vì cái điểm này nó đã cố định với cái tâm này rồi. Nên là khi thay đổi kích thước ở các vị trí này ấy, thì cái điểm ấy nó sẽ không di chuyển nữa, bởi vì cái điểm ấy nó đã cố định rồi, nó đã có khoảng cách theo trục hoành và trục tung so với cái tâm cố định của tâm của hệ trục tọa độ rồi. Nên khi chúng ta thay đổi cái này, kể cả chúng ta có thay đổi đây là 100 này, thì nó cũng chỉ có thay đổi các cái điểm này thôi chứ nó không thay đổi điểm này nữa vì nó đã bị cố định rồi. Thì cái này rất quan trọng. Một hình mà được gọi là full constraint có nghĩa là fully control, có nghĩa là hoàn toàn cố định, và nó sẽ không phải hoàn toàn cố định mà các điểm của nó hoàn toàn có kích thước đầy đủ để cái hình đấy nó không bị xê dịch hay bị bê đi đâu, thì người ta gọi cái là full constraint. Và cái này nó rất quan trọng. Thực tế thì trên thực tế nếu mà chúng ta không fix, giả sử như trong trường hợp này các bạn không fix này, không fix cái vị trí ở chỗ đấy thì các bạn sẽ hiểu này, để thầy chúng ta không fix ở đây này thì sau này cái hình của chúng ta, khi cái hình phức tạp rồi chúng ta thay đổi, có rất nhiều giai đoạn mà các bạn sẽ phải thay đổi kích thước để sửa lại hình ấy. Thì cái việc mà nó các cái điểm này nó không cố định, tức là nó không fix vào rồi ấy, thì nó sẽ có thể dịch trái dịch phải, và hoàn toàn các cái hình mà bám theo cái hình đấy nó sẽ bị lỗi. Và đấy là một điều rất quan trọng trong cái việc mà các bạn thực hiện vẽ 2D. Ngoài ra có một vấn đề nữa đối với hình vẽ 2D, đó chính là cái việc hình phải kín. Thì thầy đã giải thích hình để kín. Giả sử bây giờ chúng ta vẽ một hình chữ nhật như này chẳng hạn, đây là nó tự động nó bắt điểm, các bạn nhìn thấy nó bắt điểm không ạ, nó bắt ở cái điểm cuối điểm. Tuy nhiên trên thực tế thì nếu nó bắt điểm không đúng hoặc hình nó lại bị hơi lệch như này chẳng hạn, ví dụ như này là nó trúng rồi này, nhưng nhiều khi các bạn sẽ không làm bắt điểm như này chẳng hạn. Đây, tuy nhiên ở đây nó rất là to, ở đây thầy sẽ phóng to cái phần này lên cho các bạn nhìn. Đây là nó bắt điểm. Giả sử cái hình to như này chẳng hạn mà hình nó chưa kín như này thì hôm nào cái này nó gọi là flow boundary trong tiếng Anh. Thì khi mà chúng ta không có flow boundary ấy, thì kể cả chúng ta thoát ra khỏi sketch rồi, thoát ra khỏi sketch để chúng ta vẽ 3D ấy, thì kể cả trường hợp mà chúng ta pass lên này, các bạn sẽ nhìn thấy là nó sẽ báo lỗi này, đúng không ạ? Đấy, nó sẽ báo lỗi như này này, cái hình của chúng ta nó sẽ báo lỗi. Sợi lịch hôm nay là lịch B1, thì các bạn chờ thì chúng ta Ôi giời, lịch B1 này. Các bạn ơi, thầy hỏi chút này. Cái lịch vẽ kỹ thuật ngày hôm nay của các bạn là lịch của B1 hay là lịch của các bạn ở trên ERP nó hiện các bạn, hay là hiện của có hiện lên ERP của các bạn không nhỉ? Thầy xin lỗi.
Có hiện ERP à?
Có ERP môn vẽ kỹ thuật.
Nó hiện ERP rồi.
Nhưng mà có vẽ kỹ thuật đúng không? Thầy hỏi chút, có môn vẽ kỹ thuật không?
Có
thế ạ.
Có à? Thế thì không phải là nhầm trong B1 rồi. Chị Huyền nhầm. Rồi thì các bạn sẽ thấy cái này nó là một cái lỗi khá phổ biến. Và trong lúc thi ấy, các bạn lưu ý này, bởi vì hình bây giờ vẽ hình chữ nhật thì nó rất là đơn giản. Nhưng trong lúc thi khi mà chúng ta tạo một cái biên dạng nó hơi phức tạp chút, thầy sẽ mô tả để các bạn tạo một cái biên dạng. Giả sử như trong trường hợp này chẳng hạn, chúng ta sẽ rất hay làm cái trường hợp này gọi là bo góc này. Chưa? Bo góc để tự động nó cắt cái phần này đi. Ngoài ra thì chúng ta cũng có thể tạo các cái biên dạng khác nhau bằng cái trục tẩy này chẳng hạn. Đây, quất chim này chẳng hạn. Thì đây. Thì các bạn nhìn đây này, cái hình chúng ta sẽ cắt biên dạng đi. Thì có một vấn đề đó là chúng ta cắt không hết chẳng hạn, hoặc chúng ta cắt quá chẳng hạn, nó sẽ dẫn đến tình trạng là cái boundary này nó không kín chẳng hạn, nó bị thừa ra. Thì hoàn toàn các bạn không thể vẽ được 3D. Và khi các bạn không vẽ được 3D ấy, thì các bạn sẽ rất xuống, bởi vì các bạn đã mất công làm được cái profile đấy. Có thể là profile thầy cái profile của nó phức tạp hơn thế này rất nhiều, có nhiều đường bo này, nhiều đường tiếp xúc, đường tròn tiếp xúc, và dẫn đến tình trạng là các bạn rất hoảng khi các bạn đi thi. Thì lời khuyên của thầy đối với trường hợp này, đây là lời khuyên và thầy cũng lưu ý các bạn, và đặc biệt là khi các bạn đi thi, đó là chính là trường hợp nếu cái hình đấy mà nó đã có lỗi rồi ấy, thì để tìm ra lỗi đấy, một này các bạn dành thời gian 2 phút để tìm ra cái lỗi đấy, nó chưa kín ở đâu. Còn nếu trong trường hợp mà bạn phóng to thu nhỏ rồi mà không biết cái lỗi ở đâu cả, thì lời khuyên duy nhất của thầy đối với trường hợp đấy là các bạn vẽ lại cái hình 2D. Các bạn lưu ý với thầy nhé, vẽ lại, bởi vì nếu các bạn loay hoay ở đấy thì sẽ tốn rất nhiều thời gian và tìm rất khó. Biệt là những cái hình như này mà các bạn phóng to này, vì nhiều khi bạn nó mỏng mà nhìn xa như này thì nó cứ như là nó kín, nhưng mà thực tế là khi phóng to nữa thì lại hở. Nhưng trong trường hợp này thì là kín ở đây, bởi vì cái đường này nó đã báo ở đây luôn rồi thì nó sẽ kín. Tuy nhiên có nhiều cái hình nó phù khòng mà do các bạn xoắn bằng các công cụ tool bằng tay ấy, nó không hợp lý và nó bị thụt vào, nên cái profile đấy không thể tạo ra hình 3D được. Và khi các bạn không tạo ra hình 3D mà bạn loay hoay mãi cái sketch đấy thì nó sẽ tốn rất nhiều thời gian để các bạn hoàn thành cái bài đấy. Và cách duy nhất là thà mình vẽ lại còn hơn là mình đi tìm cái lỗi đấy, bởi vì nhiều khi thầy đã chứng kiến rất nhiều bạn tìm cả buổi không ra được. Đặc biệt trong lúc thực hành thì thầy sẽ nói cụ thể, tại vì thực hành thì nó sẽ xảy ra rất nhiều cái tình huống khác nhau, và khi đó thì các bạn sẽ hiểu là vì sao chúng ta bỏ cái khoảng thời gian đấy thì nó sẽ các bạn đi thầy đã trao đổi với chỗ chị Huyền rồi thì chắc là khả năng là các bạn sẽ học flute. Thì hôm nay thì thôi thì chúng ta học 1 tiếng rồi, còn đâu thời gian thì chắc là để buổi sau nữa thì các thầy sẽ bố trí lại tiếp còn số thời gian còn lại, tại vì hôm nay nó đang trùng vào lịch rồi. Thì các bạn lưu ý này, một lưu ý với tất cả các bạn, vì các bạn đang ở B2 thì cũng có thể là ấy, thì lần sau mà cứ có trùng lịch mà trên ERP này ấy, thì các bạn báo ngay cho chị Huyền nhé, không cần phải kêu lên đâu cả, không cần phải được kêu qua cả. Các bạn trao đổi trực tiếp với chị Huyền, viết email cho chị ấy hoặc gửi tin nhắn gì đấy báo cho chị Huyền, kể cả môn nào cũng thế. Nếu có xu hướng mà bị trùng lịch thì phải báo ngay cho chị Huyền, bởi vì chị sẽ phụ trách việc xếp lịch của khoa của năm 2 và năm 3, nên các bạn phải báo ngay và báo sớm, chứ không để tình trạng mà cái môn nó đang bị đè như nhau là, bởi vì trường chúng ta cũng mới chuyển sang ERP thì chắc chắn nó cũng có nhiều vấn đề, và các bạn chính là người sẽ phải phản hồi lại cái đấy. Thì buổi học hôm nay thôi thì tạm thời chúng ta coi như học được 1 tiếng. Thì cái bài kia thì thầy sẽ gửi trên Classroom, thì các bạn có thể về vẽ tay ở nhà trước. Về cơ bản thì sẽ giới thiệu có 2 phần thôi, đó chính là phần vẽ tay và vẽ máy. Thì cụ thể như nào thì phần vẽ tay thì thầy sẽ gửi, còn phần vẽ máy thì thầy giới thiệu qua về phần mềm. Thực ra thầy muốn là các bạn cào rồi thì lúc ấy chúng ta trao đổi nó sẽ dễ hơn, bởi vì hôm nào đến cái buổi thực hành thì sẽ không mất nhiều thời gian để các bạn làm quen. Bây giờ cái tài khoản của các bạn mà chưa kích hoạt thì đến buổi thực hành, nếu mà kích hoạt thì nó cũng phải mất một khoảng thời gian rất dài, mà chúng ta thực hành thì chúng ta không có nhiều. Một số bạn thì máy tính ở nhà không có, máy tính không được mạnh, không cài được chẳng hạn, thì nó cũng khó khăn hơn. Nên là lời khuyên của thầy là đôi khi chúng ta qua được phần nào thì tốt phần đấy, và thứ hai nữa các bạn tập trung phần thực hành. Bởi vì hôm nay nếu mà tính buổi hôm nay sẽ là buổi về mặt lý thuyết, thì 8 bài thực hành thì đã có đích rồi đấy, thì các bạn lưu ý. Thế thôi thì buổi học thì thời thôi thì chúng ta sẽ học 1 tiếng thôi, hôm nay sẽ bù lại tốt cái phần đấy, thế nhá. Rồi các bạn nghe rõ không nhỉ? Alo.
Dạ vâng ạ.
Rồi thế nhá, thôi được rồi, các bạn thoát ra là có thể vào 1 phút được rồi đấy.
Em thầy ạ.
Ừ.
Em thầy.
Em thầy ạ.
Em thầy.
Em thầy ạ. Ừ.
Em thầy.
and able to identify the characteristic of fluid flow in pipes. For example, at home we have the water system where different pipe which is connected for water tank, let's say, on the top of the building, on the top of the house or the apartment. So we will learn about how the flow in the pipe behave different of laminar and turbulent flows. For the textbook, because I try to send the textbook on ERP, but it is too heavy, so I couldn't send it. So I put the link here. You can get the first one. We follow the textbook Fundamental of Fluid Mechanics, the 8th edition. So here has a link. You can download it from this link. Yeah? I think you need to use the USPS email, even for foreign student. In this class, we have 2 foreign students. You can access to this link. There's another reference you can use at the Introduction to Fluid Mechanics by Fox and McDonald. Okay. About the time commitment and evaluation, just got the 3 ECTS with the lecture hour of 30 hours. You will have 6 hours doing practical work in the lab 210, that is on the second floor of the A21 University building in the room 210. So we will have 6 hours doing the practical work there. So in total we have 36 hours. About the mark component, so you can see here for the attendance, you have 10%. So I will check on ERP. You will have some homework to do. So it will be 5% in total. Then you will have 20% of the midterm exam. So it will take place probably on the 5th or on the 6th lecture. Okay. Practical work. So here you will do some experiments in the lab, and then you analyze the data that you get, and then you write a report for the practical. Okay, and then final exam, it will be 50%. So for both exam, you will have some multiple choice question plus with some writing. So it means that there are some exercise that you need to write the detailed answer of the question. Okay, that's for very basic of the time commitment and evaluation that you should follow. For the homework, I asked academic assistant to create Moodle course. I hope that this afternoon you will be enrolled in the Moodle course platform. So I will write the instruction on Moodle. So we will submit the homework on Moodle. Okay. At the moment, I think the assistant not yet enroll you, so we take a little time. I will also upload the syllabus. Let me show you the syllabus of the course. Okay. So here, exactly what I introduced from beginning. So you have the course learning outcome reference the assessment for the mark. So for the main content, we will learn in the first lecture with about introduction. So we'll see, we'll come back to this later. Okay, we will have some practical work for each section. There are 8 chapter. I will, if Moodle work well, I will upload this also on Moodle so that you can have a look on it later. Okay. Is there any question until now? Still 10 students not showing up yet. No question. So I will continue. Okay, so here we are. So for the course container, so before the introduction, fluid static, element, fluid dynamic. So the chapter 3 with Bernoulli equation. This is one of the most important equation in fluid mechanics, but I hope you will understand it well. There will be a lot of application. There are a lot of application in our daily life using this Bernoulli equation. Then you have fluid kinematics, fluid control, volume analysis. So here in this part, we have method to analyze a fluid mechanic problem using some idea about the volume, fluid volume, and the mass content. For chapter 6, differential analysis of fluid flow, this is one of the most difficult one. And actually, I will give it to the end of the course. If we have enough time, we will have a quick look on this chapter. Otherwise, it will be let's say a reference for you to read at home. Okay. Then you have dimensional analysis, similitude, and modeling. So this part will be related to the practical work as well. And the last part about viscous flow in the past. Okay. For today, for the first chapter, you will learn about, let's say that when you learn something, I think fluid is something very new to you for this course. So you will learn about very basic thing about the dimension and list of some physical quantities related to fluid mechanics and calculate value of some common fluid properties that given accurate information. Then you learn about fluid compressibility, use the concept of viscosity, vapor pressure, and surface tension. We will not go into one by one for all the chapter. So I will skip it. We will upload the slide after we finish the lecture. Okay. So now I should check the attendance for everyone here. You can see also Đấy. Ok. Ờ, Cao Đức Anh. Maybe I will take the screenshot, but I want to see the face if you are here. So I will read twice if I didn't hear the signal from you. Okay. Cao Đức Anh,
có.
can you turn on the camera and everyone? Cao Đức Anh. Ờ, Lê Đức Anh.
Có.
Okay, I see your face. Cao Đức Anh. Lê Đức Anh, are you here?
Có.
Yes. Nguyễn Đỗ Trung Anh.
Có.
Guys, can you all turn on the camera? Nguyễn Đỗ Trung Anh, yes. Trần Thái Anh. Trần Thái Anh.
Có.
Ok. Trần Vũ Minh Anh.
Có.
Ok. Vương Chí Bách.
Có. Luôn.
Yes, Bách. I did not see the camera.
Thấy chưa?
Ok. Dương Quốc Bảo. Dương Quốc Bảo.
Có.
Yes, ok. Cao Bảo Châu. Ok. Lương Đình Thành Doanh.
Có.
Ok. Lê Minh Đức. Lê Minh Đức. So, Lê Minh Đức is not here. Ngô Văn Nghĩa Dũng.
Có.
Ok. Đỗ Hải Dương.
Có.
Let's see the photos. Hứa Ngô Đại Dương.
Có.
Ok. Nguyễn Mỹ Đường. Look on the name. So missing one. Okay. Nguyễn Mỹ Đường not here. Trần Nguyễn Bảo Dương.
Có.
Ok. Trần Ngọc Dương.
Có.
Hoàng Văn Giang.
Có.
Nguyễn Trường Giang.
Có.
Nguyễn Phương Hà. Nguyễn Phương Hà. Second time. Not here. Nguyễn Ngọc Huy. Nguyễn
Có.
Ngọc Huy. Ok. Vũ Gia Huy,
Có ạ.
Hoàng Văn Khải, Hoàng Văn Khải, second time, not here. Phúc Khánh,
Có.
okay. Xuân Khôi, Xuân Khôi, second time, not here. Khôi, you here, right? Okay. Okay. Vũ Đào Khôi,
Có.
okay. Hà Ái Lam, Hà Ái Lam, not here. Phạm Tùng Lâm,
Có.
okay. Clement Lin, are you here, Clement? Clement not here. Đỗ Nguyễn Tiểu Long,
Có ạ.
Đỗ Nguyễn Tiểu Long,
Có đấy ạ.
yes. Đỗ Tuấn Long, Đỗ Tuấn Long second time.
Có.
Nguyễn Hữu Hoàng Long,
Có.
Bùi Duy Lương,
Dạ em có.
Nguyễn Tắc Mạnh,
Có.
okay. Hoàng Minh, Thao Hoàng Minh second time. Nguyễn Như Minh, Nguyễn Như Minh,
Có. Có.
Nguyễn Hữu Minh,
Có. Có.
Võ Minh,
Có. Có.
okay, Võ Minh. Hoàng Minh,
Có.
okay. Trần Khánh Nam,
Có.
Nam, why don't you turn on your camera? Nguyễn Quang Nam, giờ xin delay. Nguyễn Quang Nam,
Có. Có.
okay. Nguyễn Cao Bình Nguyên,
Có. Có.
okay. Nguyễn Khôi Nguyên,
Có.
okay. Lê Minh Nhật,
Có.
Lê Minh Nhật, okay. Trịnh Đình Phát,
Có.
okay. Nguyễn Hồng Phúc,
Có.
Nguyễn Hồng Phúc,
Có.
yes, okay.
Yes.
Đoàn Ngọc Minh Quân,
Em có ạ. Em có ạ.
your camera.
Em đây ạ.
Nguyễn Hoàng Quân, okay. Nguyễn Hoàng Quân,
Có.
okay. Thái Đình Quân,
Có.
okay. Trần Hồng Quân,
Có.
okay. Lê Minh Quang,
Có.
Phan Anh Quốc, Phan Anh Quốc second time. Trần Đình Tâm, Trần Đình Tâm, second time not here. Trần Minh Tâm,
Em
Trần
có.
Minh Tân, sorry.
Em có.
Trần Minh Tân, okay. Ngô Đức Thành. Ngô Đức Thành. Second time not here. Trần Tuấn Thành.
Có.
You are Ngô Đức Thành, right?
No, no, Trần Tuấn.
Okay, I see Ngô Đức Thành. And then Trần Tuấn Thành.
Có.
Trần Tuấn Thành, okay. Trần Vĩnh Thuận.
Cũng có.
Thuận.
Có.
Okay. Nguyễn Khắc Tiến. Nguyễn Khắc Tiến. Not here. Khắc Tiến. Lê Thanh Toàn. Lê Thanh Toàn, second time. Toàn đây nhìn sao thấy gì thấy. Em nói to lên nó hiện pop up lên trên Zoom của thầy mình. Và bật cả cam. Sao nó không hiện lên trên Zoom.
Alo thầy ơi.
Lê Thanh Toàn, ok. Nguyễn Khắc Toàn.
Có ạ.
Ok. Nguyễn Đức Toàn.
Không có ạ. Có ạ.
Phạm Minh Chiết. Minh Chiết. Minh Chiết, not here. Nguyễn Anh Tuấn. Nguyễn Anh Tuấn. Phan Anh Tuấn.
Có ạ.
Okay,
Có Phan Anh Tuấn ạ.
okay. Victor. Victor Varane. Varane. Victor, are you here?
Yeah, I'm right here.
Can you see not show up here? Yes, 251001. Can you turn on your camera, please? So can you say something again? I don't see on Zoom, but somewhere. Có nghe gì không ạ? Can you hear me well, everyone? If you cannot hear me well, just you can chat directly here, okay? Ngô Đức Việt.
Có.
Okay. Quang Vinh.
Có.
Anna Voisin.
Yes.
Okay. Lê Quý Vũ. Lê Quý Vũ.
Có.
Okay. And Nguyễn Hoàng Vũ.
Có. Có.
Okay. So some student.
Thầy ơi, em tên Lam ạ. Em có nhưng mà hồi nãy em bật mic thì không nghe.
Hải Lam.
Vâng ạ.
Em nói
So
thầy ạ.
you can hear me, right? Nào nhỉ?
Trần Đình Tâm thầy ơi, em chết nữa thầy ạ. Em bật mic có vấn đề thầy ạ. Với cả mấy em học cam đấy.
Trần Đình Tâm.
Trần Đình Tâm ạ.
Trần Đình Tâm. Trần Đình Tâm. And then next student. Nguyễn Khắc Tiến. Tiến, yeah, I cannot hear you. That's why. Minh Chiết. Okay. Nguyễn Phương Hà. So some student, that's why I cannot hear you. That's why I asked you to turn on also the camera. Anyone else? So I will go from the list from beginning. Okay, let me look at here. If you can, if you cannot say because of microphone or the connection, can chat directly here. Okay, let me look not here, right? Nguyễn Mỹ Đường, are you here? No. Hoàng Văn Khải, are you here? Khải, no. Clemence, are you here? No. La Hoàng Minh. La Hoàng Minh, not
Yes, yes.
here. La Hoàng Minh. Okay. Phan Anh Quốc, are you here? Phan Anh Quốc, not here. And Nguyễn Anh Tuấn. Nguyễn Anh Tuấn, not here. Okay. So 1, 2, 3, 4, 5, 6 students not here. Okay. Let's go back to the slide. So I finished check the attendance. So please pay attention. For the next time, I hope that we will study at USDA or at Chùa Láng campus. Okay. So for this course, what I would say use the textbook that I show you how to use this textbook. I forget. This is important because this is a very large textbook. We will not learn all of the chapter in this textbook, but only first 8 chapter. Okay. So here's the textbook. Maybe some of you already downloaded it. All right. So you can see that we have, if you open the table of contents, you can have introduction. In each chapter, there will be learning objective, it's divided into different sections, like characteristic of fluids. At the end, you will have, so this is the same structure of all chapter. Okay, you will have chapter summary and study guide. So normally you can read first the learning objectives and chapter summary and study guide before you dive into the detail. Okay, you have also some important equations that they summarize here, and then you have some reference. You can, if you want to go into deeper, so you can read some reference here. And then you have the problems. So for the homework, please pay attention. I will give some exercise as homework in this part problem. Okay, the page will be you can see the label on the top right or top left of the textbook. So 32, for example, and then you will have the appendix parts. So there are some important information that you will read in this part. Appendix B, you have physical property of fluids. So here in this appendix, you will have, for example, table B.1. You will have the physical property of water, and it will give you in different unit system. Like you have DG units, you have physical property of water of the in the SI unit system, standard international unit system. So you can see, for example, here we have temperature, because the property of fluid is changing depending on the temperature. You can see that the density, the specific width, dynamic viscosity, etc. So you will use, please note that don't use Google, but use the physical property of fluid from the appendix of the textbook, like this table B.1 or B.2. Okay, so don't use Google, but use the appendix of the textbook. So I want to emphasize that. So everyone for this course we will agree in the same data, same reference. Okay, so you can see in the appendix C you have property of the US standard atmosphere. For example, compressible flow function, ideal gas. Then you have also some answer to selected problem. So you can compare the result to this. Okay, they give you directly the final answer. So you can compare with that. And then if you continue, you have another approximate physical property like of some common liquids, also in BG unit, in SI unit. So you will use the appendix for the exercise. So please remember that this is very important. Okay. So let's go back to slide. Okay, so fluid mechanics is a branch of physics that concerned with the mechanics of fluids. Remember that for the fluid in English, it divided into liquids and the gas, and then the force on them. For this course, the old name in Vietnamese is cơ học chất lỏng, but actually the correct name should be cơ học chất lưu. Sorry for some French students. I want to explain a little bit for them, because if you just say cơ học chất lỏng, it means that only liquid, but for chất lưu, it will also consist of the liquid and the gas. Okay. So fluid mechanics have application in a lot of discipline, including mechanical, civil, chemical, biomedical, engineering, geophysics, astrophysics, biology. For example, you have to study about the air that flow through the car, or they had to optimize the gas engine. So here, if you classify them, you can see the first first photo you can see by the airfoil of the aircraft. If you see the wing of the aircraft here, if you make a cut on the wing of the aircraft, so you can have the airfoil. So they need to study how the airflow going through or above and below the airfoil in order to optimize the lift. The lift, that is a force to help the aircraft overcome the weight of the aircraft. Or we can study in another field like what happened with the lava that erupted from the volcano. Okay? Or in the country like Vietnam and maybe even in France, you have some important water dam that to keep the water for produce the electricity or for safety of the human, also for agriculture, etc. Or even in medical, you say that you can study about the blood pressure that vary in our body. Yeah? or go further, go to the let's say for students follow the astrophysics or cosmology, you have study and evolution of the dust and gas in the universe. So how the planet formation, sorry. So fluid mechanics can be applied into multidiscipline. Okay, and we can divide fluid mechanics into 3 divisions. The first one is fluid statics. So static, it means that the fluid will stay at rest or not moving. So we study the mechanics of fluid at absolute and relative rest. Rest is not moving. Okay, and then you have fluid kinematic, that you will deal with translation, rotation, and deformation of fluids without considering the force and energy that causing the motion. And last, we will have fluid dynamics, that describes the relation between velocity, acceleration, and now for dynamic, we will consider about the force exerted on or upon the moving fluids. Okay. If we study fluid mechanics and is specialized in the matter, we can classify aerodynamics. So aero, it is the I think that is the Latin word meaning the air. So when we study the fluid mechanics, consider the flow of the air. It is very important in optimization of the airflow. Like, for example, you make a simulation of the airflow going through the car to optimize the drag force that flow through the car, or like the airfoil of the aircraft that I mentioned before. And then the second, that is hydrostatic and hydrodynamic. So sitting concentrate on mostly on the motion of some fluid, especially of the water. Okay. And there are 3 approaches to the fluid mechanics. This is similar to many other subjects actually. So we can do experimental. Then we have also theoretical and computational. It means that if we know some prior knowledge, we can predict what will happen. And to verify that, we can first using the computer to make some simulation, and then we can make some experimental to verify with the simulation, compare with simulation and the theory that we have. Okay. That is the approach that we have. And for simulation, nowadays there are a lot of applications that can help us to make the simulation. In the previous year, for the practical course, I be student, because in the previous year there are 12 hours of practical. So that's quite a lot actually. So normally there will be 6 hours of simulation. So we will make some model using software like COMSOL multiphysics, and then you run the simulation to see what happens with the flow. Let's say that you have a simple pie, and then you want to predict, you want to see how the velocity of the fluid going through the pie and the pressure distribution in the pie, what happened with that. You can easily to do that with the application like COMSOL multiphysics. Okay. Now there are a lot of other software. The last, the newest one we have is 3ds. At USDA we have that application. Some other course you also use similar software. Okay. Here are some example of the fluid mechanics in daily life. For example, you had design. Actually, I already mentioned before the design of hydraulic system, the dam, the canal, the lever, and machinery like the pump or the turbines. Or you have the fluid control device, can be both pneumatic and hydraulic. Then you have the design analysis of the gas turbine, rocket engine, supersonic aircraft. Or in our body, you have human circulatory system. So we study about the fluid of blood in the vein, pumping action of the heart, etc. Yeah. So what is fluid actually? So you know that there are four different phases of the matter. So it can be solid, like in this example, you have the apple. You can hold its shape easily. Okay? Or you have another phase of the matter, that is the liquid. So for the liquid, you can use some container to keep the liquid, like the water. So you can use some bottle, keep the water, or some cup, okay? Or even mercury, kind of metal, but also considered as a liquid, or blood, or soda, or coffee. Okay? And then you have the gas. So for the gas, there are no distinct safe, like the air, carbon dioxide, helium, oxygen, or propane. And the last type, that is plasma. So during the, especially in the country like Vietnam, we have a lot of storm. So you can have very high electric current of the lightning that will change the atmosphere into plasma form. Okay. Or at the very high pressure and temperature of the star, the plasma also is there. Okay. For engineer, so they define the fluid is a substance that deforms continuously under the application of a shear stress at any magnitude. So if you wave your hand in air, you can see that we interact directly with them easily. And for engineer, we define them as a substance that deform continuously. So for the table, if you try directly with your hand at the moment, or with your mobile phone, you try to squeeze that or you try to push us, it will not deform unless you apply very, I would say, very large force. Okay, but for the water or the air, it will deform continuously when we interact with that. Okay? And the shear stress can cause the deformation of material by acting a force along the plane parallel to the impulse stress. Yeah? And the liquid and gas are the different phases that we can take. So you can see the figure here is how the fluid will behave compared to the solids. The impulse stress, thus the fluid will continuously deform easily. Okay. Normally for this course, I recommend you to take note. If you study offline, the mobile phone and laptop or even iPad will not allow during the lecture. Okay, so in the slide I will put some let's say some highlight of some important definition or principle, and also some equation because this course is new to you and there are a lot of new definition and also equation. It's very hard to remember. So I strongly recommend you to take note. So please use a textbook to write down. That is the first time to memorize the idea easily. So you can have uh, note taking class in at your state already in the first year, I think. So please try to apply that for this course because there are a lot of exercise and equation. And in the previous years, there are a lot of students who fail this course because this is not easy course actually. So please try to do exercise, to take note, to learn hard. Okay. When we make the comparison between the solid and fluid, so you can see that for solid can resist the tangential stress in static condition, but fluid cannot resist the tangential stress in static condition. Whenever a solid is subjected to the shear stress, it will undergo a definite deformation alpha or break. Alpha is proportional to shear stress up to some limit condition, but for fluids, there are no fixed deformation, and it's the continuous deformation take place until the shear stress is applied. For solid, it may regain partly or fully its original shape when the tangential stress is removed. So just like the mobile phone, you apply small force, small stress, and it can recover it, or even it doesn't change the shape. But for the fluid, it can never regain its original shape once it has been distorted by the shear stress. Just like fluid, when you place your hand inside the water, let's say, or the air, so immediately because of the structure of molecular different, so it will change. Okay. And to distinguish one fluid from another, you can based on the molecular structure. So the spacing between molecules is very small. We can see that for the gas, the spacing between molecules of the order 10 to the power minus 6 millimeter. So from that, we can calculate the number of molecules per cubic millimeter, that is about 10 to the power 80. That is for the gas. For the liquids, the spacing is 10 to the power minus 7 millimeter, and the number of molecules is about 10 to the power 21 per cubic millimeter. So we can see that the very big number. So to characterize the behavior of fluids, we will take into account the parameters on average or macroscopic scale. So we consider the fluid as a continuum. Okay. We will be dealing with variety of fluid characteristic. So we will need a system for describing the characteristic both qualitatively, such as the length, the time, the stress, and velocity, and also to describe the fluid characteristic quantitatively. It means we need the numerical measure of the characteristic. So in fluid mechanics, we will have 4 basic or 4 primary quantity. In fact, in mechanics, we will have 7 basic quantity, but for fluid, we can limit to the 4 primary quantity. So they are the length that denoted by the, so pay attention here, we have capital L, okay, the letter, that's for the length here, L, length, and then for the time, so the capital T, for the mass, capital M, and temperature, that is capital theta. And based on the primary quantity, we can have secondary quantity. So from Z, we can view on other quantities like the area, because area that is equal, so length multiplied by length, so that is square of the length. Okay. Similarly, we have velocity. Velocity that is distance divided by the time interval, or distance is given by the length. So please give me a little bit. Density that is mass per volume, so that is big M. So here we have the mass divided by volume. Volume that is length multiplied by length multiplied by length. We have the height, the width, and the length. Okay, so we have L cubic, so L M divided by L cubic, or cubic L, so that's the M multiplied by L power minus 3. Okay. And most of problem involving in fluid mechanics, we only need 3 basic dimensions. They are length, time, and mass, LTM, are required. And alternatively, we can also use length, time, and force. F stand for the force could be used. Okay, so we can use Newton's second law to make the relation between the force and the mass here. I will show you later. Okay, so the primary quantities used to characterize the property of fluids you can see in the table. So from the dimension associated with the common physical quantities. If you cannot write directly the dimension of the parameter, I suggest that you can start with the units of the parameter, and then you will convert that to the dimension. So I will try to take note here. Let me see how to do that. First. So for example, you have acceleration, right? So the acceleration that is meter per second square. So you can see that meter that is for the length, and seconds that is for the time. So that's why it is length divided by t square. Okay, or it equal length t power minus 2. Okay, so that is the idea we will have some exercise. I don't know how to do this. Clear on drawing. Okay. Similarly, here we have another other parameters like the density, area, angle, force. So for the force, that the F in the FLT system, but in the MLT, why the mass length multiplied by T to the power minus 2? I give you about 30 seconds. Think about it. Then can you answer the question? Why in mass length time system, the force is given, the dimension is MLT minus 2. Actually, I already mentioned in the previous slide about this relation, but let's try to do it by yourself to explain why in the MLT system it has a dimension of MLT to the power minus 2. Okay. Is there anyone want to show the answer? I will give you some bonus points. So the bonus point will be added to the midterm result. Okay. For example, each correct answer, I will give you bonus point of 0.25 or 0.3, let's say. So that's the way I want to encourage you to interact during the lecture. You know the answer? Someone can show the
Can I answer?
please? Yes, please.
Yes, so I think like for force is MLT to the power minus 2 is because the L and T to the power minus 2 is accelerations, and according to Newton's second law, like the force equal to mass times acceleration, so it's MLT to the power minus 2.
Yes, that's correct. Trần, what's your name?
My name is yes, Trần Tuấn Thành.
Trần Tú Thành. Okay, thank you, Thành. Yes, that's the correct answer. So I will write here. So let's see. Yes, Thành mentioned. So F equal M multiplied by A. So we convert to dimension because this is a mass multiplied by A, that is the acceleration. So that is length meter per second square e to the power minus 2. Okay, so it means that from that we can also derive mass F function of the force also. We convert F divided by this T power minus 2. Okay, easy, right? Thank you, Thành. So the primary quantities also refer as the basic dimension. Okay. Choose color. I'll take note on white. All the theoretical derived equations are dimensionally homogeneous. Homogeneous, it means that the same. Okay. It means that two sides of the equation will have the same dimension. For example, you can see the basic equation of motion with constant acceleration. Velocity at the time t will equal initial velocity plus with acceleration multiplied by the time t. Okay. So on the left side, the dimension of velocity. So because the unit of velocity that is meter per second. So meter that is the length multiplied by t to the power minus 1 equal lt minus 1 same. Okay, plus with acceleration length multiplied by t minus 2 multiplied by t. So t multiplied by t minus 2 that equal t minus 1. So both sides of equation has the same dimension lt minus 1. Okay. Now let's try to apply on exercise. So we have a liquid flow through. So here in this one, an orifice or a hole, we say that, located inside of a tank. So this is a diagram of the problem. A commonly used equation for determining the volume flow rate, let the Q through the orifice given by the equation. So Q equals 0.61 multiplied by A multiplied by square root of 2GH, where A that is the area of the orifice, G is the acceleration of gravity, and H is the height of the liquid above the orifice. So you need to investigate dimensionally homogeneity of this formula. So we need to prove that is it has the same dimension of the both sides of the equation, and what is the dimension of the both sides of the equation. So I give you 1 minute to use your notebook to work on this problem. Okay. If you want, you can use the annotate. Yeah, okay, I see the direct answer from chat. Newton's second law that E F equal ma. Yes, yeah, that's same answer. Okay, so okay. So for this exercise, you have Q equal 0.61 of a square root of 2gx. Okay. Anyone want to share your answer?
Đáp án nó chỉ cần nói là được đúng rồi.
Sorry.
Ý em là chỉ cần nói cái giải thích cái kết quả cái dimensional của Q là được đúng rồi.
Both side equation. You need to explain both side equation. Of course, because they say that investigate dimensional homogeneity. So when they have the same dimension of both side equation. Do you want to try? One. Because for Q, that is volume flow rate. So you know that for volume flow rate, like you have water. When they release the water from the Hòa Bình Dam, you heard on the television some channels that talk about the flow rate. Yeah.
Yeah, I think I have it.
Yeah, Victor.
We can the surface area is can be assimilated to L wait, I don't know how to say L at the potential wait like this in the chat.
A moment.
The chat like this.
Share and then yeah, maybe you can how to say maybe you can try to use, I don't know, each student will have.
Oh yeah, wait, I can put it on the camera. It will be easier, I think.
Yeah, that would be
okay. So
everyone can see.
Like
you can share some.
Yes. Okay, I don't know if you guys can see on the camera, but you get the equation.
I can see that.
Yeah, and so by using the A, it's an area, so it's length per length. On the little g, it's length per time divided per time by time, and h, well, is another length. So when we put it all together, we find that q is length per length divided by time, which is like homogeneous to what it should be.
Yes.
Yeah,
Is
sorry
the
for my
same
English.
for the- No, that's okay. So you have the dimension of both equations the same. Okay, so they are dimensionally homogeneity. Thank you, Victor. That's correct. So let me continue for the slide. So you can see that at the beginning, I show you the appendix that you have some table with different unit system like BG, that is a British gravitational system, or EE, English engineering system. So in the future, maybe you will work at some country like in the UK or in the US. So or you like in the India. So in the country, they do not use the international system like Vietnam and France that are using, but they use different in this system. So we will work with them. So sometimes you need to make the conversion. So to make sure that everything work well, there are no mistake in the calculation. You need to understand about the conversion of the system of units. Okay. So in fluid mechanics, we will consider three systems of units: SI, BG, and EE. In fact, BG and EE quite similar. You see. First one, just about in the SI unit system. So what is the unit of length? That is meter. Okay. The time, that is second. For the mass, that is kilogram. And the temperature, so let's guess, is degree Celsius or Kelvin. It can make the vote Kelvin or degree Celsius. Is there that kind of option to no, I don't know if we have that option to make the vote. Okay, I will go directly. So because of degree Celsius are used in daily life, so we normally think maybe degree Celsius is the unit of temperature in the SI, but no, the temperature unit in SI, that is Kelvin, and Kelvin 1 degree, 1 Kelvin, not degree, just Kelvin. Okay, that equal 1 degree Celsius plus with 373.15. Okay, so we can use this equation to convert between Kelvin and degree Celsius. Note that for temperature, Kelvin without the small little dot here. Only you for degree Celsius, degree Fahrenheit, degree Rankine, that you will see later. Okay. And then you will have the unit of the force, that is 1 Newton. 1 Newton, that is equivalent to, so you have the Newton second law, 1 kilogram multiplied by 1 meter per second square. Or you have for the work, you have 1 joule equal 1 Newton multiplied by meter. So when you apply for force to an object that move a distance of 1 meter, so the work that you have done, that is 1 joule. Simple. Okay. Or the power, you have 1 watt equal 1 joule per second, or equivalent to 1 Newton multiplied by meter per second. So if in the problem they give you the parameter in millimeter or in tons for the mass, you should convert to meter and kilogram. So we will easily to find other parameter if we agree using on the same unit system, especially like in the temperature, because if you use a thermometer at home, you measure the temperature of the room is 25 degrees Celsius, but for the problem, when you apply the equation, you need to convert back to Kelvin. Okay? So for that, you will need to add with this number. So this is very important in solving the problems. Okay? Another example that is letter G that we also saw in the previous exercise. That is gravitational acceleration of the Earth. So the value we can make the approximation of about 9.81 meter per second square. Besides the unit, standard unit, we can say that for SI, we can use a prefix for unit for SI unit. So we can use, for example, if the number is very large, in order of 10 to the power 15, we can use a simple P that stands for peta, or tera, giga, mega, kilo, hecto, deca, deci. If it's very small, we can have centi, milli, micro, nano, pico, femto, atto. Okay, so the prefix will help us to reduce or quickly read the value of the parameter. So normally we will encounter with giga, mega, kilo, centi, milli, micro, and nano, and the other is very rare to see. Okay. And in the British gravitational system, in BG system, the unit of the length, that is the foot, at the time, that is seconds, the same. And in SI, the force is a pound with the letter LB, okay, for the force, that is pound. Temperature, that is degree Fahrenheit, F, degree F, or the absolute temperature unit is Rankine, degree Rankine. Okay. For the mass unit, it is slug. It's not pound, but slug. And also defined from the Newton's second law. So you have 1 pound force. So sometimes you read some textbook, they will write explicitly the LBF. So normally in the EE system, they will write LBF or simply write 1 pound. This is the force. So don't confuse with the mass. Okay? In BG system, this is the force. 1 pound will equal 1 slug divided by 1 foot per second square. And the weight of the mass, that is pound also. Okay? Because the weight equal the mass multiplied by gravitational acceleration mg. So, and for the pressure, so for fluid mechanics, of course, you will use this parameter a lot of time. Pressure, that is PSI, or can be PSF. I should put it here also. PSI and PSF. PSI, that is equal 1 pound per inch square, or PSF, that is pound per feet square. Okay. So some value like the Earth standard gravity, we have G. Where's mix color? Red, see it easier. For the Earth standard gravity, the value, so we can take it directly. Approximation value is 32.2 feet per second square. So we can make the conversion. 1 slug equal 32.174 per mass. Okay, this is if you use a mass in E system, that is per mass. 1 slug equal 32. In UK, they use per mass. Okay. In daily life, they use per mass, not kilogram. And we can make the conversion. 1 slug equal 14.594 kilogram. So it means that 1 pound will equal about 0.5 kilogram. 1 pound mass equal about 0.5 kilogram. I don't remember exactly, but you can use a calculator to make the conversion. 1 meter about 3.2 feet. Okay, or 1 feet will equal about 0.3. So for a adult, if you walk a step, this will be equivalent to about 0.3 meter, 1 feet. And then you have 1 Kelvin will equal 1.8 degree Rankine. Okay, 6 degree Rankine here. Okay. Okay. In the E system, the unit of the length is the foot, same as in BG, time is second, force is pound. So they write explicitly LBF, power force. The absolute temperature unit is Rankine, degree Rankine. So mass is pound, LBM. Okay. So here in the previous slide, we had 1 slug equal 32.174 per mass. So between BG, in the BG, they use 1 slug. In the EE, they use per mass. Okay. And here also the same conversion between SI to EE, same as in SI to BG, 3.281 feet. Okay. This figure showing the comparison of SI, BG, and E units for the length, mass, and the force. Okay. Force. So we have Newton convert to pound. So Newton equal 1 meter multiplied by 1 kilogram per second square. So to convert to the force, you simply convert from meter, that 1 meter equal 3.28 feet, and then multiply by kilogram to the slug. So we convert back. So you multiply by slug divided by second. So that will be the value that you found. Okay. So here's a table to show you again. If you write the parameter in primary dimension, so the equivalent. So we have the mass, that the MLT, temperature, theta, and the force EF, and in SI will be kilogram, meter, second, Kelvin, Newton. In BG is slug, foot, second, degree Rankine, pound. For the force, okay. Here in the EE, for the mass will be power mass, foot, second, degree Rankine, and power force. So you can see that in EE, they write explicitly power mass and power force because we use the same power for the two. So to make the separation, so we have power mass and power force. But for British gravitational unit, you will have slug and you have power. Okay. Here you can take a note for degree Rankine. It equal degree F plus 400 59.67. Okay. In the textbook, you have the appendix that you can use that directly the conversion factor from SI unit to BG and E unit. So you don't need to convert by yourself. Actually, you can do it by yourself, but you can use this quickly. Okay, like the acceleration from SI to BG by multiplying with 3.281. That so you can see in this only different in meter and feet. So that is 3.281. Similarly here for the length, okay, that's same number or velocity. Okay. Then you have another like meter square, so should be double it. Density, energy, force, length, I forgot. So actually sometime in BG and EE they give you the value of the length not in feet but in inch. Normally you heard about the inch. Okay, so 1 feet will equal 12 inch. So we can make a note here. 1 feet will equal 12 inch. Okay, so I can see before you have PSI and PSF. That is for pressure. That is power per inch square and power per feet square. Okay. Now let's try to do this exercise. This is a way we will apply for the conversion of the unit. So we have a tank of liquid having a total mass of 36 kilograms pressed on a support in the equipment bay of the space shuttle. Determine the force in newtons that the tank exerts on the support shortly after liftoff when the shuttle is accelerating at 15 feet per second square. So note that we have g equal 9.81 meter per second square and 1 feet equal 0.3048 meter. So please try to do this. I say 2 minutes to do this exercise. To finish this exercise, yes, 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 Khôi. Can you use the annotate? Can you try to use the annotate so everyone can see? Click on Zoom and click on annotate, and then maybe you can use a draw or text like this. So for everyone, or yes, you can share the screen. Yeah, you can share on the Google screen. I stop sharing my. Yeah. Yes, I saw checking part. It is the answer 517.8 Newton. Yes, that's the result that we are looking for. I believe that many students select the same answer. Student, I just want to check. You can check yourself if you check the attendance on ERP, right? You can see it by yourself, right? I already put the attendance of the lecture on ERP, so I hope that you can check it by yourself. So note that for this course, you had 30 hours of lecture. It means that it divided by 3 hours per lecture, so 10 lecture. So if you absent 4 lecture, then you are not allowed to do the final exam, and you have to redo the course next year. So as a policy of the university, you are only allowed to absent maximum 30%. Okay? So please be careful on that. So please tell with your friend about this policy of the university if he or she are not aware. Okay, can you share your screen? Yes, you're drawing. Yes, I think everyone can see your screen. Mm-hmm. So that is the correct answer. Yes. So only notice point that in this exercise that you need to convert the acceleration of 15 feet per second square to meter per second square. So in order to do that, you just multiply by 0.3048. Okay. And then apply the questionnaire right here.
That is khối, right? That is khối. Yeah, only one khối in this class. Khối. Okay. 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 Let's go. Maybe we take a break of 15 minutes. 1-5. Okay. So let's go back here. At 3:55. Okay. We have one break of 15 minutes, everyone.
Go back to the lecture. So from beginning, we have learned about dimension, system of units. Now we move to properties of fluids. Okay. So the property of fluid result from the intermolecular interaction. Actually, we already seen in the previous slide that we have the structure of gas and liquid. They are spacing. So this spacing actually decide the property of the fluid. So molecular fluid are spaced farther apart. The intermolecular force are smaller than for the solid, and the molecule have more freedom. And the individual interaction is quite difficult to quantify. So fluid properties are studied by the Loop effect or the Coulomb effect. So we will use the continuous hypothesis to study the property of the fluids. That is a macroscopic behavior of the fluid is perfectly continuous and smooth, and the flow property inside small volume will be regarded as being uniform. So if let's imagine like you take a vacation and then you go to the beach, or you look at the sand on the beach, and you see that it consists of a small grain. Okay, you look closer, zoom in to the sand, you can see that there are small rock and big rock, then small grain and big grain. So that is when you zoom in by microscopic view, like you can see in this figure, there's a big difference between small and big grains. But if we looking at farther from the beach, like you view from above, like from some hotel, you can see that the beach is very smooth and very hard to identify where is a big grain, where is small grain. So we can mark it as when we study the flow properties, will be regarded as being uniform. Okay. So common property of fluids are described by, so first is the mass. So we know that the mass is the scalar quantity described by the density of fluids, and velocity, that is a vector quantity which determines the momentum of the fluid. Velocity, that is vector quantity, so it will have both magnitude and direction. And then you have stress, that is a force per unit area acting on the fluid particles. Then you have viscosity, that defines the ability of the fluid to move freely. You can go into details later. Okay. Then you have thermal fluidity, that is the ability of fluid to transfer heat through system. Okay. So let's see with some basic equation first. We have density. Density is defined as the mass per volume. We've seen before, the unit of the density in kilogram per cubic meter in SI or slug per cubic feet in BG. So note that most of the English textbook, you will see that they use the letter density for density, they will use row. So this is the row, the Greek alphabet. Row, okay, row for the density. Because I know in high school in Vietnam, we will let the T for density, but from now on, we will use row. It's a slide here for density. Okay, density, that is ratio of the mass per volume. Okay, so you need a kilogram per cubic meter or slot per cubic feet. Okay. So for liquid, the variation in pressure and temperature generally have on a small effect on the value of density. But for the gas, density is strongly dependent on pressure and temperature. You can do the change of the density easily by using the pump. If you have a pump at home, or you can, I'll say like when blow a ball, so you can change the density and also the volume and the pressure easily for the gas. Okay? Here is a chart or the figure showing the density of water that vary with temperature. At 4 degrees Celsius, the density of water is about 1000 kilograms per meter cubic. And then when we increase the temperature, then the density of water will decrease. Okay? So when we change the temperature, the space of the molecular in water will increase. So when the space increase, so the number of molecular in 1 meter cubic will decrease. So that's why the density will also decrease. Okay. So this is similar and many other fluids. And especially for water, we can see here it has very specific maximum density at 4 degrees Celsius. Even you can see that at lower temperature, density actually slightly decrease. So quite special. Another term that you have that is specific weight, gamma. So here gamma, okay, of a fluid that is defined as weight W per unit volume V, and which can be related to density air. Gamma will equal W divided by V, weight divided by volume. Because the weight that equal mass multiplied by gravitational acceleration mg divided by v. So gamma will equal rho multiplied by g. Okay? Density multiplied with the gravitational acceleration. And the unit of gamma is Newton per cubic meter in SI unit system or pound per cubic feet in BG system. And so we can see that density is used to characterize the mass of a fluid system, and the specific weight is used to characterize the weight of the system. Okay? So you can see the question. Then we have specific gravity, Hg, define a ratio of the density of fluid to the density of water at 4 degrees Celsius. So remember, we have density of water at 4 degrees Celsius is 1000 kilogram per cubic meter. So if you have a tank of 1 cubic meter, 1 by 1 by 1 meter, 1 meter by 1 meter by 1 meter, then you put water in that tank, then the mass of that water tank will be 1000 kilogram, neglected the mass of the tank, okay? Or 1.94 slugs per cubic feet. So the question for SG will be rho density of the fluids, so the fluid we are talking about, divided by the density of water at 4 degrees Celsius. Okay. So we can see that from the density, specific weight, and specific gravity are all interrelated. So put a note here, singular density, rho, and specific weight, gamma. So the first two, you can use the Greek letters to indicate, but for specific gravity, you will use Hg. Okay. So we can determine density of mercury, Hg is that in mercury, and Fi, and busy unit system, knowing that the specific gravity of mercury is 13.55. This is the question. Okay. So for this question, how do you do that? Very simple. We are looking for the rho. Okay. Rho of mercury will equal Hg multiplied by rho of water at 4 degrees Celsius. So if because in the slide we already have the density of water, the 1000 kilogram per meter cubic. So in Fi, we have rho of mercury equal 13.55 multiplied by 1000. Okay. Similarly for in busy unit system, equal 1.94 multiplied by 13.55. Okay. So you can see that for specific gravity, because it's the ratio of density divided by density. So it doesn't have units, or we can say dimensionless. Okay, it is dimensionless parameter, and it will have the same value in all unit system. Okay, yes, dimension. less liter or same value in our system. Okay. Now let's move to Idegas law. This is important for the gas. Okay. Normally the Idegas law just because we know the gas are highly compressible in comparison to liquid. So with the change in gas density, we directly related to the change in pressure and temperature through the equation. So PV equal nRT, where you have P, that is the pressure of the gas. So it can be in Pascal, in atmospheric pressure, ATM, or in other units. Okay? Then you have volume of the gas, and that is number of mole of gas. That is a universal gas constant, and P, that is absolute temperature. So the Idegas law is a simple equation that describes how gas behave when we change the condition like pressure, volume, or temperature. Okay? And in this textbook, the standard form of the Idegas law will be given like P equal rho R prime multiplied by P. Note that R prime here is different than the R universal gas constant, where we have R prime equal R divided by N. Okay, so we can prove that equation by, so because we have PV equal nRT, N number of molecules, so it equal M divided by big M, okay, and multiply by T, and equal M by R divided by N by T. So we put R prime here. So PV will equal M R prime T. So finally we will have P will equal M divided by V R prime T or equal rho R prime T. So in this textbook, actually we will write simply the equation. So from now on, we can use P equal rho RT. Okay, and we use the Idegas law because you will, for the problem, you will have the specific gas constant value. It means that the value of a given fluid or a given gas. Okay. And note that the pressure in the Idegas law would be expressed as an absolute pressure. Okay, which means that it is measured relative to absolute zero pressure or empty space. And we have another term that is gauge pressure. The gauge pressure is measured with respect to the local atmospheric pressure. Okay. So from that, the absolute pressure can be obtained from the gauge pressure by adding the value of atmospheric pressure. Okay. So you can see that the P, so it will be right here. So P gauge will equal P absolute minus P atmospheric. Okay. It will tell you how much higher or lower the pressure is compared to the normal air around us. So most of the pressure measuring device like the car tire gauge, blood pressure, or air compressor, so use the gauge pressure because we usually care about how the pressure compared to the surrounding air. Okay. And the standard sea level atmospheric pressure is 101.33 kilopascal, but absolute 6 psi absolute. So this is pound per inch square. Okay, you can convert to pound PSF easily. This. Now let's try to do this example. Compressed air tank. So in the figure, I have balloon up. So we have V equals 0.84 cubic feet. The temperature is 70 degrees Fahrenheit, and the atmospheric pressure is 14.7 psi. When the tank is filled with the air at a gauge pressure, so I mentioned in previous slide, normally for the air compression, you will get the gauge pressure. So this value is 50 psi. Determine the density of the air and the weight of the air in the tank. So note that 1 psi equal pound per feet square, psi pound per inch square, G specific gas constant. So we need to use this value. Specific gas constant of the air equal 1,716 pound feet divided by slug degree Rankine, and 1 feet equal 12 inch. So you see that in this exercise, it is important to convert the degree Fahrenheit to degree Rankine. So we can use this equation to convert from degree Fahrenheit to degree Rankine by adding 459.67. Okay? If some of you not yet noted equation, so please write down now. So you can use that for this exercise. Okay, please take the note for this equation. So let me write here for you also. F459.67. Okay. Now, then for the ideal gas law I mentioned before, we will use P equal rho RT with R that is a specific gas constant. So in this exercise, you have R of the air. R of air equal 1716 feet pound per slug multiplied by degree Rankine. Okay. So what you need to do to convert all of them to the busy system. Okay. We have slug per feet, cubic feet, and weight in pounds. So this means we are calculating the value in busy system. So 14.7 psi, you need to also convert to the true value here to PSF in order to calculate the density and the weight. So I can say that you need to find density and the weight and rho. In the type. Okay. So note that for the Ideas law, P equal rho RT, I mentioned before, you need pressure and absolute P absolute is equal P gauge plus P ATM. So in this exercise, it is equal 14.7 plus 50 psi. Okay? Or it is equal 64.7 psi. But because we are looking for the result in busy system, so we need to convert to PSF. Yeah. So if we want to convert PSI to PSF, because 1 feet equal 12 inch. So it means that from this 64.7 PSI in equal 64.7 multiplied by 12 square or 12 multiplied by 12. Okay, that is we need here SF. Okay, we have power per foot square. Then for the temperature we have 70 T equal 70. Before I take the notes for you, someone drop connection. So degree Rankine or degree Fahrenheit plot with 459.67. So you can put it here plus with 459.67. Okay. And then finally you can write rho equal P divided by R by T. So we put all the values that we have here. For the pressure, that we have 64.7 multiplied by 12 multiplied by 12, and then divided by 4.7 140. Okay. divided by, so R that is a specific gas constant of the air, 1716 multiplied with 7 3 plus, so this will be 529.67. Okay, so that will get 0 something. So unit, the density in this unit is exercise will be slug per cubic feet. Okay. Similarly, for the width, it will be very simple. Width will equal m multiplied by g. So they give you the volume. You know the density before. So density m will equal rho divided by the volume and multiplied by g. Okay, rho that you have in this calculation, and v equal 0.84. Okay, and g is given here. Okay, so you plug on the value in the equation, and you will obtain W, and the unit will be slug per multiplied by feet per second square, or that is pound. Okay, that is for this exercise. You can make the calculation by yourself. For the other lecture, please remember to bring the small calculator with you, so that if you have some exercise, we can use a calculator to calculate the value. Okay. Now let's move on to viscosity. So the property density and specific weight are the measure of the heaviness of the fluid, and it is clear, however, that the property are not sufficient to uniquely characterize how fluid behave, because the two fluids like water and oil can have quite the same value of the density, but still quite differently. And you know, for the oil, it can float above the water because the density of the oil is smaller than density of water. Okay, so artisan property needed to describe the fluidity of the fluid. So that one is viscosity. Viscosity is quantity that describes the fluid resistance to the flow. So the fluid resists the relative motion of the immersed object through them, as well as to the motion of the layer with differing velocity within them. And in simple terms, viscosity means friction between molecules of fluid. Let's take the example. So here between water and oil, but let's say if we use instead of water, we can use honey. You know, honey produced by bees. So if you pour the water and pour the honey out of the box, you can see that because the water is less viscous, so it will flow everywhere on the floor. But for the oil or the honey, it is more viscous or have higher friction. So the honey or the oil will not flow everywhere on the floor, but they will be concentrated close together. And you can see on the figure here. Okay? So we can go into the deeper about the viscosity. Consider we have a hypothetical experiment in which a material is placed between the two very wide parallel plates, like in the figure A here. Okay, So the bottom plate is fixed plate. Okay? On the top, it is can move freely. So if a slit like the stem were placed between the two plates and loaded with the force P, so the top plate would be displaced to some small distance, delta A. Okay? So the vertical line AB here will rotate through the angle delta beta. Okay? And delta beta that equals the shearing strain. And in fact, for the elastic solid like the stem, we can expect that we will have small angular displacement when we apply uh, the applied force P on the upper plate. Okay? So now, if we replace the solid with the fluid like the water, so we will notice the major difference. So the applied force P applied on the upper plate, it will move continuously with velocity u, and this behavior is consistent with definition of fluids. That is, if shearing stress is applied to the fluid, it will deform continuously, as we seen in very beginning of our lecture. Okay. So the applied force P here we call a shearing stress tau. Okay. So this letter here is called tau. Okay. Develop on the plate material interface, and in order to for the equilibrium occurs, it means that at some moment when equilibrium happens, then the plate is not moving anymore, and we have balance, and so P will equal tau multiplied by A. A that is the area of the upper plates. Okay. So, and the fluid, and we can see that the upper one will move with the velocity maximum u, and at the bottom with the zero velocity. So we can see that we have a velocity gradient. So we can see on the figure gradient, it means that it will vary by the direction from the bottom to the up. So it increasing linearly in this case. Okay? Maximum u, small it is 0. So the distance between two plates is small b. Okay? Z direction is y axis. Okay. Assume that. So the fluid between the two plates will move with velocity u as function of the y axis. So u, y, and vary as u will equal u multiplied by y divided by b. B is the distance between the two plates. So we have a velocity gradient du over dy is developed in the fluid between the plates. Okay. And the experiment shows that the shearing stress is proportional to the rate of shearing strain. We have gamma dot equal u divided by d and equal du over dy. Okay? Du over dy, that is the velocity gradient. Okay. Rate of shearing strain, that is y dot. Okay. Not. So du over dy, that is velocity gradient. That is gamma dot. So if you learn latex, you probably know about this, how to apply the equation. Okay. And we have rate of shearing strain gamma dot win equal U over B and equal du over dy. And it is proportional to tau. Okay. Tau that is a shearing stress that developed in the material. And tau is equal mu multiplied by the U over dy, where mu that is the absolute viscosity, or it is called the dynamic viscosity of the fluids, and it has the unit of Newton second per meter square. Okay. So we can see in this figure, we have rate of shearing strain. It means that how velocity will be vary in the y direction. The rate of shearing strain of some fluids. So we have the air at 60 degrees Fahrenheit. Shearing stress is small. Then if you have water at 100 degrees Fahrenheit, water at 60 degrees Fahrenheit, and you have crude oil at 60 degrees Fahrenheit. So shearing stress crude oil very large compared to water and the air. Okay? So in simple, what we can say is that viscosity is equal to how much force is needed to slide one layer over another at a certain speed. Okay? You look at this equation. Clear. Okay. So why viscosity is important? Because see that in engineering, we can have effect of the pump design or lubrication in the engine. In aviation, you have the air viscosity will affect the drag on the wings. Okay, so at the beginning, we can see that the design of the wing. In medicine, you have blood viscosity will affect to the health and circulation. Okay? For example, some people they drink a lot of beers, they will have the blood with what is that in English? What's the word? But it's some people they eat a lot of meat and drink a lot of beer will have somehow they will have very bad effect on the health because the blood circulation will reduce. Okay. And for fluids for which the shearing stress is linear related to the rate of shearing change, like in this equation, also refer to the rate of angular deformation are designed as Newtonian fluids. Okay? And in contrast, the fluids for which the shearing stress is not linear related to the rate of shearing change are non-Newtonian fluids. Okay? And the slope of shearing stress versus the rate of shearing strain graph is denoted as the apparent viscosity mu AP. And most of the fluids and gas are Newtonian fluids. So we have apparent viscosity equal dynamic viscosity. And it is independent of shear rates. Some non-Newtonian fluid we can have like toothpaste. So every day you use toothpaste for brush clean your teeth. Okay, or yogurt, or lava, etc. And for shear thinning fluid, the apparent viscosity decrease with increasing the shear rate. It means that the harder the fluid is shear, the less viscous it becomes. So for example, like the latex paints, okay? Or you can have the water sand mixture. The difficulty in removing an object from the quicksand increase dramatically as the speed of removal increase. Okay, and for shear thickening, so for shear thickening fluid, the apparent viscosity increase with the increasing shear rate. So the harder the fluid is shear, the more viscous it becomes. So this should be for the quicksand, the mixture between the sand and the water. And the first case here is for the shear thinning fluids, the latex paint. Because for this one, the latex paint will not rip from the brush because the shear rate is small and the apparent viscosity large, but it can flow smoothly on the wall because the thin layer of paint between the wall and the brush. Okay. Other type is Bingham plastic, which is neither a fluid nor a solid, and such material can withstand a finite non-zero shear stress. We call that a tau yield, zero stress without motion. Okay. But once the zero stress is exceed, it will flow like fluids. So toothpaste and mayonnaise are common example in plastic. So we can see some example shearing stress with the rate of shearing change for fluids. So here you have Newtonian fluid. So linear function. No, for linear function, it is straight line. Non-linear, it will be a curve. Okay. For Bingham plastic, when the zero stress exceeded some value, some critical value, then we will have the rate of shearing change and shearing stress a function of linear function. Okay, Bingham plastic. So today lecture, I think we can stop here. Quite long until now. I will check with Miss Yuan, assistant of Department of Technology and Engineering, if Moodle platform is ready. If it is ready, then I will upload some homework on that, and then you will need to do that. Otherwise, I will send you the email. Okay, please to finish the homework and be part of the mark as an assignment. Okay, 5% of the mark. So, do you have any question for today's lecture? Some student. Otherwise, we can stop here. I wish you have a good evening and see you next time. Okay, bye.
Bye.
Em chào thầy ạ.
Hello thầy.
Em chào thầy ạ.
Chào các em.
Thầy đúng không?
Thế slide hôm nay thầy up ở đâu thầy?
Chỉ có thể là up trên Moodle thôi, tại vì thầy trên ERP nó đang bị lỗi rất là nặng, file nặng sẽ không up được. Chắc là thầy sẽ up lên Moodle cho hệ thống cho các em nhìn. Thầy đợi xem chị trợ lý chị tạo Moodle cho thầy nhé.
Vâng, cảm ơn thầy, em chào thầy.
Chào em. Các bạn nào mà không tập trung thì chắc ngồi dưới